Hello. In this video, we're going to use a multi-layer perceptron, which is a type of neural network, to control a synthesizer that has 10 control parameters using just 2 control parameters that are in an XY control space. And we're going to do this using a strategy called regression. When we use regression, a neural network predicts output values that could go to anything from a set of input values that could come from anything. When we train the neural network, the first thing we have to do is collect a set of input and output example pairs. So, for example, here we have a set of input examples that each have 3 values, which corresponds to our 3 input circles here. And each of these input examples has a corresponding output example that has 2 values, just like our 2 output circles here. And each one of these input examples and output examples share a common identifier or ID to keep track of which inputs belong to which outputs. What we're going to do with all these examples is we're going to take them one by one and feed them into the neural network. We're going to send the input example into the input of the neural network, and at the same time we're going to tell the neural network, when I show you these input values, I would like for you to return these output values. And what this is doing is that each time the neural network receives an input example, it makes a guess on what it thinks the output values should be, and then checks against the output values I provided it to see how wrong it was. And then depending on how wrong it is, it'll correct itself a little bit so it can be more accurate next time. And after doing this training thousands and thousands of times, it starts to get pretty good at predicting the output values that I want it to based on the input values that I show it. So after this training is complete, we're then able to show it some values that it has maybe never seen before. And it's able to respond with an output that, although is not an example that I showed it, would sort of fit inside of the training data that I did train it on. So one way to think about this is if these blue dots are all of our data points and they sort of fit in this space in this sort of curved way, the neural network is able to learn this red curve that represents the general shape of my data. And that way, if I give it an input value that is not in the training examples that I showed it, it goes to this red curve and then is able to identify, if this were an input point, what output point would this correspond to so that it fits within my training data. Because I said the inputs could come from anything and the outputs could go to anything, we can start imagining that this could be used in all sorts of different ways. We could have a control interface be the input to the neural network, and then the output be controlling synthesis parameters on a patch. And this is actually what we're going to do today. Also, it could be from some sort of wearable or other input device. The input could have something to do with the audio analysis, like the pitch or loudness of a signal. And the output could be something else, like live visuals for a performance, perhaps. But really, that could be anything. And once you learn how to use a neural network for regression, the real creativity comes into what you're connecting it to and how you're using it musically. So this is the max patch we're going to be using to do this. And what I have here is a 2-dimensional input control space, just an XY controller, that is outputting values between 0 and 127. If we just look at the Y position here, it goes from 0 up to 127. I'm taking those 2 integers and packing them into a list and then dividing both of those by 127, so that what I'll end up with is a list of 2 values that will range between 0 and 1. So here's 0, 0, 1, 1, and then all of the different positions in my XY space. And then on the right-hand side here, I have a synthesizer algorithm in this patcher, Chaos X Synth, that is controlled by 10 parameters. And those 10 parameters are being right now being controlled by this multi-slider that has 10 sliders. So as I move all these values, it changes the parameters inside the synth. We can take a listen to some of these. Okay. And what we're going to be doing is sending these 2 values of my XY controller input space to this neural network that will then predict 10 output values that will be sent to this multi-slider and eventually control the synthesizer. So the first thing we have to do is create our input and output example pairs that we'll use to train the neural network with. So we need to select a data point of these 2 dimensions and a data point in these 10 dimensions and then pair them together. And when we pair them together, we're going to be adding them to data sets. So the first thing I'm going to do is make the data sets that we'll add them to. Fluid.dataset, and then I have to give it a name. Perhaps I'll call this one XY data. And then I'll make another data set. Maybe I'll call this one Synth params. So this is the data set that we'll add our XY positions to, and this is the data set that we will add our synthesis parameters to. Now before we start adding these data points to our data sets, we first need to write the data into a buffer. So I'm going to create some buffers to do that. Buffer tilde, I'll give it a name, XY buff, because it's the buffer I'll be writing my XY values into. Now, you may have used buffers in Max before to hold audio files, which often have 44,100 samples per second. So for each second of audio, there's 44,100 values. We don't need a buffer that has that many samples in it, because we're only going to be storing 2 values in there. The X and the Y position. So we're actually going to tell this buffer exactly how many samples we want it to have by giving it the attribute @samps2. And then we'll also need a buffer for storing the synthesis parameters. So we'll make another buffer. We'll call it synth params buff. And we'll give it the attribute @samps10 because our synthesizer here is controlled with 10 values. So now we have to write the XY positions into the buffer. And we're going to do that with an object called fluid.listToBuff. And what list2buff does is it's going to take values in a list and write them into the buffer. We have to tell it which buffer to write into using the attribute @destination. And for here, we're going to write into XY buff. Now, if I connect this to here and move this around, maybe up some high values, and then look in the buffer, we can see that sure enough, there's 2 high values in there. If I move it down lower, or maybe I'll make them different, 1 low and 1 high, and then look, sure enough, we have our values being written into that buffer. We're going to do the same thing with the synthesis parameters. So I'll put a fluid.listToBuff over here, give it the destination synth params buff, and then I'll connect this list of values to this buffer. And if we put some values in here and look at it, that looks correct. If we put some different values in here and look at it, that looks correct. So we have those values being written into that buffer as well. Okay, so now that we have our XY control values being written into that buffer and our synthesis parameters being written into its buffer, we can start adding these values to our data set. Now the way that I'm going to do that is I'm going to start with a bang and put a little comment here that says add point. And so when I hit this bang, it's actually going to add a point to both the dataset XY data and the dataset synth params so that they can be paired together with the same identifier. Now in order to create this identifier, I'm going to use a counter so that each time I hit the bang, I get a unique integer. And then with that integer, I'm going to combine it with the word example hyphen, and then S stands for string. The integer that the combined object receives will be converted into a string and combined with the word example. And I need to put one more attribute here, and that's @triggers1. And what that's going to do is make the first inlet, because we always start counting from 0 in these cases. So this is the 0th inlet. This is the first inlet. So it's going to make the first inlet hot so that when this integer comes into that first inlet, it will trigger an output, combining that integer with the word example. So if we just take a look at this here, see what's coming out. Each time I click add point, it gives me a new identifier with the word example and an integer that'll make it unique. Great. Now the way that I actually add the data points to the data set is with a message add point. And the first argument for this message is going to be the identifier. So I'm going to put a $1 here so that we can pass that identifier to this message and it will put it in the correct place. And the second argument is which buffer the data set should go look at to see what data is there and add it to the data set. And so for the data set XY data, we're going to use XY buff. And for the data set synth params, we're going to do the same thing, but we're going to tell it to go check out the buffer synth params buff. So now if we connect all this up here, let's just take a look at what's coming out of these. And we can see that what we're getting is we're getting a message telling that we'll send to the dataset XY data, telling it to add a point. That identifier should be example 40. That data point should be whatever values are in XY buff. And at the same time, we get a message that we'll send to synth params saying add a point. The identifier should be example 40. And that data point should have whatever values are in the buffer synth params buff. And the important thing to notice here is that they both have example 40, so that when it comes time to train the neural network will know that this set of XY values corresponds to this set of synth parameters. So let's start adding some data points. Now, the way that I'm going to do this is I'm going to first find a sound that I like. So I found a sound that I like, and now I'm going to choose a position in XY space that I want to correspond to that sound. And since this sound has some higher frequency content, maybe I'll choose to put it up a little higher in the XY space. So I'll choose to put it right here. Now that I have this where I want it, I have the sound that I want, and I have this where I want it, I have it in the XY position that I want, I'll hit add point. Now if we go and look at the data set, we can see that those points have been added to their corresponding data sets. And we'll do that with a message print. We can see that the dataset synth params has one row, which means it has one example in it. The ID for that example is example 41. And that example has 10 columns, which means that it has 10 values in it, which is good because that's how many values our synthesizer is controlled with. And the dataset XY data also has one row, just the one example that I added to it. That example's ID is also example 41. And it has just 2 columns, meaning it has 2 values in it, which is good because those are my XY positions. So now we can add some more points. So maybe I'll find another sound I like. And then I will choose a new position. Maybe I'll put that one right in the middle. Have this where I want it, have this where I want it, hit add point. Do another one. This where I want it, put this one down in the lower in the space, perhaps it's kind of a lower frequency, which is just my own choice to put it there. It doesn't have to go there, but it helps me remember later maybe where I'm putting these different sounds. So I have this lower sound here, put a point just a little bit lower in the space, add point. Maybe do a couple more. Maybe I'll put this one also down low, maybe down in this corner. So I have this where I want it, this where I want it, add point. I'll do this one too. So maybe I'll put that one up here because I haven't put anything in that top corner yet. Got the sound that I want, the position I want, and I'll click add point. Okay. So now let's print the data set and take a look at it. They both have 5 rows, which is good. That's how many points I added. They both have the identifiers ranging from example 41 to example 45, 41 to 45. And all of my data points in synth params have 10 values corresponding to my 10 synthesis parameters that were set at the time that I added the point. And the XY data points all have 2 parameters or 2 values corresponding to the XY position of this dot when I added the point. So now that I have my input and output examples selected, I can use those pairings to train the neural network. I'm going to do that with a message called fit, and fit here is synonymous with train. It's like we were looking at earlier. We're fitting a curve to our data. And fit takes 2 arguments. The first one is which data set has the input points. Here it is XY data. And then the second one is which data set has the output points, and that is synth params. So before I hit fit to do the training, I'm going to put a message box under here, because when it is done training, it will dump out some useful information for us. So I'll hit fit, and it reports back fit, so it's completed its training. And it gives us a value here, and this value is called the loss or the error, and this value represents how inaccurate or how wrong the neural network still is at performing the task I've asked it to perform. So what it's doing to train is it's taking all of my input values, my XY positions that I provided, and it's feeding that into the neural network and then making a prediction as an output. And then it's checking that output against the output that I actually asked it to learn and calculating how wrong it is from the output that I asked for. And so this value, the loss, is a calculation from all of those errors, overall how the neural network is performing. So a lower loss value is better, meaning that it's more accurate. It is less wrong. And this value is actually still somewhat high. So we want to do some more training to train the neural network to be able to make better predictions or more accurate predictions. And we can do that by just hitting fit again. And when I do that, it's not going to reset the neural network and start over. It's just going to pick up from where it left off and do some more training to learn the data even better, and then hopefully have a lower loss value that it reports back. And we can see that the loss went down, so that's great. Now I'm going to draw your attention to this attribute here, max iter. And we're not going to talk about all of these attributes in this video. I'll put in the description a place where you can find more information about the attributes for MLP Regressor. Max iter specifies the number of epochs that the neural network should do when I hit fit. And an epoch is when the neural network uses each one of my input-output pairs once. So a max iter of 1,000 means that 1,000 times the neural network is going to train on each one of my input and output pairs. So when I hit fit, it does 1,000 epochs and then reports to me how well it is performing or what the loss or error is. So if I hit it again, we can see it will go down even more. Now there's a nice thing we can do to sort of watch this loss go down. And for that, we're going to use a multi-slider and put it into style reverse line scroll. And we'll also set the range from 0 will be our lowest, and then this is already at 0.15, so maybe we'll make this 0.2. And we'll need to route the fit value into here, and then we'll do some more training. If we can see that it's still going down, we can see this sort of series of loss values here. It's going down quite a bit now, and at some point we can see that it starts to level out. And so this neural network is starting to level out at a loss of about 0.03. It's still going down a little bit, so we should keep training. But at some point, it will not be improving very much with each one of our fit presses, at which point we can probably stop training it and use the neural network. So here it's really starting to flatten out at about 0.02. And I think that'll be a good place to stop. So now that we have our neural network trained with our input and output examples that we provided it, we can start using it to make predictions. In order to do that, I just need to send it a message, predict point. And predict point takes two arguments. The first one is which buffer the neural network should go look at to get the values that it should use as the input. And since our input values are our XY positions, and we're already writing those XY positions into a buffer, we'll use the same buffer, XY buff. And the second argument is a buffer where it should put its predictions when it's done calculating. So we're going to make a new buffer for this. We're going to call it predictions. Better make that buffer. And because our neural network has been trained to output 10 values, we'll say @samps 10. So now, if we put our XY controller in some position, tell it to predict point, what it's going to do is go look at this buffer, which we actually have right here, get the values out of it, use those as input to the neural network, make a prediction about what the output should be, and then write that prediction into our buffer called predictions. So I'll say predict point. This has reported to us predict point, so it says it's successfully made a prediction. And if we look at this, we can see there are some values here that are our output prediction. If I change my input, say predict point, and then look again, we have a different set of values. So the neural network is now successfully making predictions from our input space into our output space. So this is great. The thing that I really want it to do, though, is every time I move this dot in my XY space, I want it to make a prediction from that, and then take that prediction and send it straight to the synthesizer so that this XY controller is controlling my synthesizer. If we just take a look at what is coming out of fluid buff to list here, every time that it writes into the buffer, it just reports what the buffer is. We can actually use this message and just connect it to predict point, and that will just cause the neural network to predict a point every time this buffer gets a new value written into it. So if we put this up here and look at the buffer, we have some values, and if we go over here and look at the buffer, we have some new values. So that's working. We're getting those predictions made automatically whenever I change my input control space. And now, because the neural network reports to us predict point each time it makes a prediction, we can actually route our predict point so that we can receive a bang every time a new prediction is made. And we will use this bang to connect to an object called fluid.buffToList, which will go look at a buffer, take the data out of it, and then create a list and send that list out. So we need to tell it what source buffer it should use, which is going to be the buffer where the prediction was made, which is called predictions. And we'll just put a message here to see what's coming out of it. So this bang will trigger this object to take the values out of the buffer and create a list. Okay. Great. So now that we have our values coming out of the prediction buffer and being turned into a list here, I'm actually going to just connect it to this multi-slider. And that's going to take that list of values, set those in the multi-slider, and also send them to the synthesizer to change the synth parameters. So now if we change our XY space, it is also changing the synthesis parameters. And so now we have our completed patch of controlling this synthesis algorithm with 10 control parameters using just the 2 input control parameters of our XY space. Now, one of the great things about using a neural network to do something like this is that if we don't like the mappings, we can just retrain it. I'm going to do that by sending a clear message to both the data sets. And if I clear them and then print them, we can see that, in fact, they are both empty now. And I will also send a clear message to the neural network to completely reset it. And now I can just choose some new input and output pairs and train the neural network again. So here's some sounds. Maybe I'll put this one over here. Oh. So this error that I'm getting is because it's telling me that the neural network hasn't been trained yet, so it's unable to make a prediction. So I'm actually going to disconnect this predict point message so we don't try to make predictions with the neural network, and then I can move this around without getting that error. So I'll find, so I have a sound I like, I'll pick a spot for it up here. Got this where I want it, this where I want it, add point. Do a few more. Maybe this one goes down here. This one can go right in the middle. Oh yeah, this one go over here. Maybe this one can go down here. Okay, print these guys. Each one has 5 points. Synth params has 10 columns. XY data has 2 columns. Great, and then I can hit fit. Again, our value is 0.21, so we can do some more fitting here and see it come down. Oh, it's coming down very quickly this time. That's nice. This seems like a good place to stop. So now that we have it trained, I'll reconnect my predict point message and then see what we get.